Oh my God. Oh my God. Oh no, I ain't messing with you. Oh no. Oh no. Oh no, I'm not messing with you.
What's up, guys? The wardrobe theme this week is t-shirts from my band. I'm wearing t-shirts that the band I was in when I was in college made. We were called Wolfgang and the Wombats. We played a type of music called ska, which is 90s music that's a mixture between punk rock and horns and trumpets and stuff like that. So if you want an example, look up bands like Five Iron Frenzy, the OC Supertones, Real Big Fish, Suburban Legends, Streetlight Manifesto, bands like that. This week we're going to dive into how to use the number of valence electrons in an atom to determine its charge. So this is something that's very important. It'll explain a lot about the behavior of atoms. So lately we've been talking about valence electrons, and valence electrons are the single most important thing for understanding why atoms do what they do. Because when we look at the periodic table, some atoms are reactive, some of them are unreactive, some of them just hang out and do whatever they want, some of them don't do anything at all. So the way that we explain this is by valence electrons. And valence electrons, just to recall, are the electrons on the way outside of the atom. They're the farthest outside atoms that electrons that are on an atom. And so atoms will use valence electrons to do bonds, to perform chemical reactions, to do all sorts of things. So the number of valence electrons will determine an atom's behavior. Now, most atoms will make bonds until they get to 8 valence electrons. So for the example here of nitrogen, we see that nitrogen is in group 15 right here. So that means that it has 5 valence electrons. And if we were to draw the Lewis structure, we would go 1, 2, 3, 4, 5. And so the way that we would determine the number of bonds that nitrogen would make is we would look at the number of empty spaces, right? There would be 1, 2, 3 empty spaces. So a typical nitrogen atom will make 3 bonds. And that's because nitrogen and any other atom wants to have 8 valence electrons, but they only have 5. So that means they need 3 more in order to get to 8. And the way that they'll make those 3 more valence electrons is they will perform bonds. They'll undergo bonds with other atoms. Now, here you might have noticed that when I asked for examples and stuff like that, or when I asked you to do a problem, I spent most of my time on this side of the periodic table. I never really got into the metals or anything like that. And I'm about to show you why, because things are a little bit more complex when we get to the metals. So the big lesson here is that for metals in group 1 and 2, it's easier to lose a valence electron than to gain. And so for example here, let's take sodium. So this is a sodium atom. It has 11 protons, 12 neutrons, and 11 electrons. And I want you to notice something here. How many valence electrons does sodium have? Well, it's in group 1, so we know that it only has 1 valence electron, and that's it right there. Okay, so it has 1 valence electron. And now here is a really important question. Okay, really important question. Is it easier for sodium to gain 7 more valence electrons, or is it easier for it to just lose the one that it has? And of course, it's easier to lose the 1 valence electron that it has, right? Because look at this. If this valence electron goes away, then its next outermost layer has 8. Do you guys see that? How this next outer layer has 8 valence electrons, and so it's far easier for sodium to get rid of 1 valence electron than to gain 7 more. So now instead of having 11 electrons, Now sodium has 10. Now, here's really the point of this video, because we're going to determine the charge of atoms based on their valence electrons. Well, let's imagine a scenario where sodium actually did give away this extra electron. In that case, what would its charge be? Right? We're asking the question, what would sodium's charge be if it lost its one valence electron? Well, in this case, we would have 11 protons still, and those are positively charged, but now we would have 10 electrons, which are negatively charged. And I hope you can see here that right now, and I'm making kind of an arrow here. There we go. So I hope you can see here that there is one more proton than there is electrons now. And because there's one more proton, the charge, therefore, of sodium would be +1. And when you find sodium in nature, right, like in salt and stuff like that, you will almost always find it with a +1 charge. And this is the reason why. It is far easier for it to lose its one valence electron. But if it loses one electron, then that means that there's now more protons. And so there's now a +1 charge. So just to rehash this point, for metals, it is easier for them to lose their valence electron. And so here, this is the periodic table that I'm giving you this week. You'll notice that up here it says for group 1, it loses one valence electron, and it therefore has a +1 charge. Now, the same thing for group 2. Group 2 has 2 valence electrons, so they will want to lose those 2 valence electrons and have a +2 charge. All right, so just to do another example, let's try magnesium, right? What would be the charge of magnesium? Well, notice here, magnesium has 2 valence electrons. Now, is it easier for magnesium to gain 6 more valence electrons or to lose the 2 that it already has? And obviously, it's easier for it to just lose the 2 that it already has. So imagine that these 2 valence electrons are gone. Now the next highest layer has 8, but what would the charge be? Well, notice something here. We have 12 protons that have a positive charge, but now we have 10 electrons that have a negative charge. So what would the overall charge be? Well, there's 2 more protons than electrons, and protons are positively charged. So that means that magnesium would take on a +2 charge. And that's exactly what you see in nature. Exactly what you see in nature, and here's magnesium over here, right? Exactly what you see in nature is that magnesium takes on a +2 charge whenever it can. That's its natural state. And that's because it needs to lose those 2 valence electrons in order to have a full outer layer. So that's the metals. They tend to lose valence electrons. But for nonmetals, which are in group 14 through 17, way over here, it is far easier for them to gain valence electrons. And so their charge is going to be different. Let's take, for example, oxygen. How many valence electrons does oxygen have? Oxygen's right here. Okay. Oxygen is in group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. So, how many bonds is oxygen likely to make? Well, we've already done this, right? There are 2 open spots, so oxygen is going to make 2 bonds. But now the question is, what will its charge be? Well, oxygen wants to have 2 more valence electrons. If it has 2 more valence electrons, then it will get to 8. Now let's imagine a scenario where it would get those 2 valence electrons. Let's imagine a scenario where it actually does get those 2 extra valence electrons. Well, now we have 8 protons that are positively charged because the atomic number of oxygen is 8. But now we have 10 electrons which are negatively charged. So what's the overall charge here? We see that there are 2 more electrons than protons. So that means that the charge is going to be -2. And so you'll see over here, all of these group 16 elements are going to tend to take on a -2 charge because they want 2 more valence electrons, and if they got those 2 more valence electrons, they would take on a -2 charge. All right, so all of these guys over here in groups 14, 15, 16, 17, all of them will take on a negative charge because it's easier for them to gain 4 electrons than to lose. Now, obviously over here in group 18, they're not going to form any bonds because they already have 8 valence electrons, and they will have a charge of 0 because they don't need to give away any electrons. They don't need to take in any more electrons. They are already good, so their charge will stay 0. So just to summarize, to determine an atom's charge, you need to find its number of valence electrons. Then you need to ask yourself this question: how many valence electrons does it need to lose or gain in order to get 8? All right, you determine that number, and then you ask yourself another question: what would be the charge of the atom if it got what it wanted? So if it were to gain the electrons that it wanted, or if it were to lose the electrons that it wanted to lose, what would its charge be? And that's kind of the strategy you have to take to these problems. So what I'm going to do now is I'm going to take you guys through your assignments. So this is not your exact assignment, okay? It is not your exact assignment. This is just an example. If you want to look at the assignment, it's on Google Classroom. There's instructions and stuff like that. This is just an example. So, but what you will do is you are going to answer some questions about an element on a separate sheet of paper. Make sure you use like a dark pencil or pen or something like that. And you're going to answer these questions on that piece of paper, and then you will upload a picture of that paper. Okay, so the first question: what representative group is iodine a part of? Well, let's find iodine. Over on the periodic table, iodine's over here in group 17. And so group 17 is what's known as the halogens. So the answer to this first one is that iodine is a halogen. How many valence electrons does it have? Well, here, iodine is in group 17, so that means it has 7 valence electrons. What would its Lewis structure look like? Well, iodine is right here, and then we would go 1, 2, 3, 4, 5, 6, 7. Okay. What will its charge be? Well, notice it has 1 open slot. So what would its charge be if it got that extra electron in that spot? And here the answer would be -1. Okay? Because if it got an extra electron, which is negatively charged, it would then take on a -1 charge. So how many bonds will it form? It will form 1 bond. Okay? So that is what you're going to be doing for, I think, 4 different elements. Okay? It's not going to take you too long, especially if you use your periodic table and stuff like that. Remember, I'm available for contact, email, Zoom, Remind, all those sorts of things if you have any questions. That's it for this video. I hope to see you on Zoom if you have any questions. Get your assignments done.